So we're continuing with graphing rational functions. Not rational functions, circular functions. You will need a whiteboard. So we're going to be doing a lot of check for understanding type stuff. But our goal today, and I always make sure you guys get down the goal, that you'll be able to graph more complex trig functions. Okay, so you're going to have multiple transformations in your functions that you're asked to graph, as well as write equations of trig functions from the graph and also from real-world situations. And actually, we probably won't get a chance to get to the real-world situations, but we'll save that for Monday, I guess. We are going to start off with the whiteboards first, okay? You have a graph here. It says find the amplitude and period of the graph, then give the equation of the graph. So, think about it a little bit, okay? First you got to figure out, is it going to be sine or cosine? So write that down. What do you think it is? Because you're going to do this on your whiteboard, okay? All right? Now, find your amplitude. Remember, think about what amplitude is. We talked about it on Tuesday. We kind of went back over with a little bit with your problem of the day. All right? Write it down, what you think it is, and then hold it up. All right, put them down. Someone tell me, what is amplitude? What's amplitude? Raise hand. The height of what?
Of the graph. The highest point of the graph gets the max.
So that's the max.
That would be the max. Gotta be a little careful about that description. It is the height of
the top to the whatever you want to call it.
Min
Zero.
to the max.
you could do so from the min to the max. Okay, my max is where,
3.
and my min is
Negative.
how far is that? How many units?
6.
So you can say that your amplitude is half the distance from max to min, which is 3, or is the height of the actual wave itself, okay? So you have this equilibrium line, this thing known as your midline, okay? The distance from that midline to a max represents your amplitude, okay? So you can figure out what line is...
I need the following, students.
All right. So yes, 3 is your amplitude. It's the distance from your midline to a max, or the distance from your midline to a min, okay? So our amplitude is 3, all right? Now think about period. What do you think the period is? Write it down on your whiteboards. What do you think the period is? And then hold it up. Who can tell me what the period is? Matthew?
Oh.
No, I mean like in general. Like definition wise.
Until it repeats itself.
The distance it goes, the length before the graph decides to repeat itself, okay? And in this case, we would start here at 0. We go up. We go down, and we go back up. After this point, it's going to continue to repeat the process, and that is a total length of 12. So our period is 12.
2 pi. 2 pi equals 12.
All right? So now we have to write the equation. If you recall, when we broke down each one of the transformations, the horizontal stretches, compressions, that dealt with like amplitude and the period and all those good things, what number went in front of the sine function? What number will always go in front of the trig function? The amplitude. And we found out that the amplitude was what?
3.
So that goes in front of the sine. Okay? And then what went over here to the right of sine? That's where the x would go. And what number would go in front of the x? What letter was represented?
B.
B. Okay? In general, you have A sine bx. Now, if you're wondering, where did that come from? Anybody wonder where that came from? Everyone remembers where it came from?
Does anyone have any questions about that?
All right. B is in relationship to the period. Now, there was a formula that you guys wrote down to help you find the
2
period.
pi over B.
2 pi over b. This equals the period. So to find b, the number that's going to go inside with the x, you have to set 2 pi over b equal to what number?
12.
12, the period you just found, and solve for b. How would I solve for b?
2 pi over 12.
Divide by 12. So you would have pi over 6. And there's your equation for your graph.
there's no pi in the graph itself.
True. But remember, we would technically be multiplying all of our big 5, like 0 pi over 2, pi, so on and so forth, by 1 over pi over 6. 1 over pi over 6 would flip it, canceling out your pi's when you multiply them.
That's clever.
Remember how we did the Ferris wheel? We still have the pi there, but there's no pi in the Ferris wheel.
Let's look at the next one, okay? I want you guys to try this one on your own, so I'm not going to break it down into pieces. I want you guys to try this one on your own. So, first, the fact that we have the graph that intersects up here at 0, 2, kind of lets us know that it's going to be a cosine function instead of a sine. Because normally cosine starts at 0, 1, and then proceeds to go down, then back up, versus sine that starts at 0, 0, goes up, and then goes back down. This one definitely looks more like a cosine function. Now, its amplitude, its distance, where's the midline? So nature, where's the midline? At 0. Okay? So what is my amplitude? 0.5 or 1/2? Anyone will suffice. Now, what's our period? Pi over 2. Okay? If it starts here, I'm trying to see where it's going to repeat itself, and that's right here, pi over 2. Okay? Another way you can look at it for your period, the distance from max to max, or the distance from min to min. Okay? Or say they only give you like half of the curve, they give you a max and a min. You can figure out that distance from max to min and then just double it to get the period. Because sometimes they'll do that. They won't give you a full cycle, they'll only give you half a cycle, and all you have to do is just double it. Okay? So now that we know that, what number goes in front of the cosine? 1/2 or 0.5. And then to find out the b that goes beside the x, we're going to set pi over 2 equal to what? 2 pi over b. So when I cross multiply, I get pi b equals 4 pi. And when I divide by pi, b equals 4.
For cosine and sine, is it always going to be together? Is it always going to be 2 pi over b?
Yes. For sine, cosine will always be 2 pi over b. For tangent, it would just be pi over b. Because the period for tangent is just pi. Okay? Now, before we move on from this, I am going to go one step further on this problem. And I'm going to ask you to write a sine function for this particular situation. Okay? Now, when I do that, when I ask you to write a sine function, is my amplitude going to change? No, it's not. Is my period going to change? No, it still has, from max to max, the period is still pi over 2. Okay? But the thing is that where does sine normally start before you do any transformations to it? 0, 0. But since my graph doesn't start at 0, 0, where is the next point that actually crosses the x-axis?
Pi over 6.
Here? It's going to be right there. Okay? Now, that point isn't necessarily pi over 6. It's halfway between pi over 4 and 0. What's halfway between pi over 4 and 0? Pi over 8. So it was actually shifted over pi over 8 units. Does everybody see that? Okay. So then there's going to be a horizontal shift. Is that going to go inside the parentheses or outside the parentheses?
Inside.
Horizontal translations are inside. So far, it's a sine function. My amplitude did not change. Neither did my b. Okay? However, I do have a horizontal shift to which way?
Right.
Which means it's going to be a?
Well, it could go either way, so
True.
you can put plus in or minus and it'll go the same way.
Because no matter what, this is still the same one. Now, if we make it negative, this is a good one. If we make it negative, that means we move to the right. The only thing is that sine normally goes up.
Wait, sweetie.
So if we did move it to the right, we would have to make this
Negative.
negative.
Yes.
But if we moved it to the left,
It'd be fine.
it would be fine. to mention? There's one more thing I need to mention. And we're going to talk about this in the not the next slide, but the slide after. You want to put in an extra set of parentheses. And you'll see why in 2 slides. Just trust me on this. Okay? But there are your sine functions for this particular equation. So besides why we got to put an extra set of parentheses, is there any other questions?
If you do pi plus, that means it's going to move to the left, right?
Uh-huh.
In that case, sine is going to start going downwards instead of going upwards.
You said to the left or to the right?
To the left.
So they should be
plus,
switched, so the
it should be
negative.
this negative on the
should
outside
be
should
to the left,
switch, right?
The plus would mean that it moves to the left.
Yeah.
So, and then it would go up, which would be the positive.
Oh, sine is the parent, not, okay.
One more. On your boards, it's just you. On you. Read the question first, and then find P and Q. So yes, this is the written, not like how we did the other ones. P represents what? The A, the amplitude, and Q represents the B, that affects your period. So the amplitude, where's my midline? It didn't ask, but where's my midline? It's 0. So then the distance from that midline to my max is 30. So P equals 30. And then Q relates to my B. It's basically what my B would be. And that's
2 pi over b equals pi over
2 pi over B equals pi over 2. Because to find B, or to find Q in this case, I need to know what my period is, which is pi over 2. Cross multiply, divide, and yes, B equals 4, which means that Q is 4. Very good. This is an IB problem if you hadn't noticed by the wording and font. Okay? So,
Well, no, this is part A of the problem. This is part A.
a lot of times this usually isn't. A lot of times it will actually just write the equation. A lot of us not see.
Difficult or something.
So, in general, okay, these are the general forms for sine and cosine in relationship to all of them. That's including horizontal stretches, vertical stretches, horizontal translations, and vertical translations. Okay, this is what I was talking about with that extra set of parentheses. Okay, if you put in that extra set of parentheses, then you can actually put the true value for A, B, C, and D. Okay. So you said if we don't put the extra set of parentheses, then we're not what?
Defining the true set of.
Well, if we don't put in the extra set of parentheses, then you remember how that one problem when I asked you to let's write the sine one, and we found that it was pi over 8, we wouldn't be able to put pi over 8. We would have to put something a little bit different. And the reason why is basically, this allows us to write exactly what that shift is. Because if we wrote it the other way without the extra set of parentheses, we would have to distribute the B through to that number. I mean, you can, but then you're more likely to make an error, possibly with your multiplication.
Would you prefer us to leave it with the extra set of parentheses?
If it doesn't ask you how to write it, I will put it with the extra set of parentheses. But if they want it in a certain way, you gotta give it to them the way they asked you for. All right? Yes.
The minus and the plus signs can change the function, right?
Yes. So this plus can very well change, meaning go up and down. This one, yes, left and right. Okay. So the A, what did A represent again?
Amplitude.
The amplitude. Okay. And remember, amplitude is always positive. Okay. Amplitude is always positive. If there was a negative out front, that means there was a reflection somewhere. B represents what?
The thing that affects the period.
It's the thing that affects the period. So basically, it's related to your cycle. Okay? It basically tells you how many times you're going to complete one full cycle. Okay? Or how long it's going to take you to complete one full cycle. C,
Horizontal translation.
it represents your horizontal translation. Okay? And by putting it in that extra set of parentheses, you can actually, if it is pi over 8, you can just put pi over 8 and move on. Okay? And lastly, the D represents what?
Vertical translation.
Your vertical translation.
So, just to be clear, if you don't put the extra set of parentheses, then you can't just put in your horizontal translation, you have to distribute B.
You would have to distribute B if you wrote it without it. Okay? So what we're gonna do is we're gonna graph some that have all four, some that have three.
On the whites.
Okay.
So that-
No, the few are gonna be in your notes, but then the last is gonna be on your whiteboard. Okay?
Okay.
Before we get there, I just wanted to show you guys a couple of different things. Okay, here's the graph of original sine. Okay, here's one where sine of 2x, you see the difference. And then here, you see how they had the extra set of parentheses? So not only does my period change, but I know that I'm moving to the left pi over 3 units. Okay, and then you see the difference there. I just want you guys to see one that's already drawn out, you know, nice and
At the
computerized.
bottom of their graph, they have a left arrow parentheses. If we're on our exam, should we write some, like, thing on theirs?
Anyway, because a lot of times they'll restrict your domain to the point where it will only probably be one cycle that you'll see. Yeah. Here's another one of tangent. Okay. Normally tangent has just one. Okay. Has just the one branch between negative pi over 2 and pi over 2, if you recall from that problem the day we did Tuesday. But now we have 2 within that one period, okay? And then on top of that, it was shifted over.
Well, you think it's where an asymptote is? Because
I
if
think
you
the
look at,
asymptote.
I think that's the asymptote right there.
Yeah.
I know that's what I'm saying. Like original tangent
Oh, okay.
would have been right here, but now it's been squished and it's been moved over. So it no longer is going to be crossing at 0. It's going to be squished and shifted over. Okay? So here's the first one we're going to graph. We got a lot of stuff going on.
I don't wanna.
We got a lot of stuff going on, but we can do it.
Well, wait, what's the thing we're doing today? Is it like negative pi to 3 pi? What are we doing?
Let's do 2 cycles. How about that? So we'll do 2 cycles. And so wherever we start, we can go for another one, or yes, it's in your notes.
Negative pi, I guess.
So we got 5 cosine 2/3 x plus pi minus 2. Let's just figure out all the things that are happening to this graph.
Too much.
First, what?
Well, it's a cosine.
It's cosine, but it's going down by 2.
Vertical stretch of 5.
Vertical stretch of 5.
Whoa, no, son.
Yes, it is, Matthew.
Why is it vertical stretch
Oh,
of
never
5?
mind, you're right.
I
Okay,
know,
so
I'm
amplitude of
like,
5.
To the 5, so basically being stretched vertically by 5. What else?
Translation to the left by pi.
Left by pi units.
Then multiplied by 3, vertically stretched by 3 halves.
Horizontally
Horizontal.
stretched by 3 halves. Okay, so if it asks you to describe the transformations, that's what you would put. Okay? Now, what if it asked you to find the amplitude? The amplitude would be what? 5. The period would be what?
6 pi. 3 pi.
It would be 3 pi. The period, you find that by doing 2 pi over what? Over b, which is 2/3. I cannot leave it like that.
Wait, why did the
Because whenever you're doing a horizontal stretch, it's always 1 over that value, and so 1 over 2/3 ends up flipping. How can I simplify this?
Multiplied by the 6 pi. 3 times 2 is 6 pi.
So my period is 3 pi. Okay? And on top of that, what if it asks you to find your phase shift? We talked about this on Tuesday.
Pi.
Your phase shift is your horizontal translation, which would be pi. And am I moving to the left or to the right? So how would I represent that? Negative pi. Because I'm moving to the left. So they could ask you it in 2 different ways. They could ask you to describe the transformations, which would be your answers in the red, or it might ask you specific type of information, amplitude, period, phase shift, vertical shift, which are your answers in the purple. Okay? So now let's graph this. I strongly suggest you do all your horizontal stuff before you do any of your vertical stuff. That is my suggestion to you. Okay? So I'm going to do it in two parts. Okay, I'm going to do all my horizontal movement in one color, and then I'm going to do my final graph that includes my vertical translations. Because I don't want to have 4 different graphs to show all the transformations. I'm just going to combine them. Okay? Question? So cosine normally starts at 0, 1. Okay? But I have a compression horizontally. My period is changing by 3/2. And I'm moving over to the left pi units. So when that happens, that means my x's are going to get multiplied by 3/2, and then I'm going to subtract pi from each of them. And that's all going to be done in orange. So 0, 1, when I multiply that x value by 3/2, it's going to be what?
0, 1.5. Right?
What's 0 times 1.5?
0.
0. And now I'm going to move it over to the left pi unit. So that point is now going to move where?
Negative pi.
To negative pi. Did everyone catch that? Yes? No?
I think so.
Maybe? No? Okay. All right. So here's original cosine. These are the points. Okay? Those black points, did everyone see that? So each one of those, all those x values are going to get multiplied by 3/2, and then I'm going to subtract pi to get the horizontal stretch and the horizontal shift. Okay? So 0 times 3/2 is 0, minus pi puts you here. This point and this point correspond to each other. Now, pi over 2. When I multiply that by 3 over 2, what do I get? 3 pi over 4. Where's that? 3 pi over 4, right here. And now I'm going to subtract pi from 3 pi over 4. Where is that going to put me? Negative pi over 4.
This is way complicated, yeah.
And you guys draw it on your own paper, which is.
Oh. Unfortunately, I forgot to click the record button, but I'll make sure for the next one that I do. One thing to do at another cycle, once you have one cycle done, guys, to get the other one, they're periodic functions, okay? They're symmetric. You see how far this point and this point are from each other?
Slow.
They're like 1, 2, 3 lines, points from each other. So 1, 2, 3. Okay? And you just continue to repeat. Alright? So 1, 2, 3 away, 1, 2, 3. And you just line it up. 1, 2, 3. Repeat this one over here. And 1, 2, 3. That's how you get another cycle. Let's do the next one. Just putting them all together. Just putting it all together. So describe my transformations. Up to. That's where that plus 2 comes from. Horizontal stretch by 3. Remember, it's always the reciprocal.
Right, 6.
Right pi over 6.
Vertical stretch by 3.
And a vertical stretch by 3. What's the amplitude? 3. What is the phase shift? Negative pi over 6. Are you sure? Which way are we moving? Left or right? So there should be a positive pi over 6. And then what's my period? It's going to be 6 pi. Because normally it would be 2 pi over b. B is 1/3. Keep, change, flip. So my period is 6 pi. These are just some questions that could be associated with this problem before they actually ask you to graph it. Okay? Now this is the cosine function. We know a normal cosine looks like.
Something like that.
Do it this way and do it
We know normal cosine looks like that. My suggestion to you, you don't have to take it, but my suggestion to you would be to do all your horizontal first, and then to do all your vertical after. Horizontal affects your x values. So what am I going to do to all my x's? Multiply by 3 to apply the horizontal stretch or shrink, and then
Plus pi over 6.
and then add pi over 6 to each of them. And then, what about my y's? What am I going to do to my y's?
Multiply by 3.
Multiply by 3, which is my vertical stretch, and go up 2. Now, if you want to make a table and find all of those values first before you plot them, you can do that too. That's just another way you can do it instead of taking it from the original graph. Because what are the x values of the original cosine function? What are they?
Pi over 2, pi,
Okay, you missed the very first one.
0.
0, pi over 2, pi, 3 pi over 2, and
2 pi.
2 pi. So you can take each one of those x values, multiply them by 3, and then add pi over 6 first before trying to put them on the graph. You can do that. Okay? What's 0 times 3? 0 plus pi over 6 is? So I know that first point is going to be a pi over 6. But you know. Let me read it. Okay? Do the same thing with pi over 2. Pi over 2 times 3?
3 pi over 2.
3 pi over 2 plus pi over 6. You have some paper, take a moment, sketch that. 5 pi over 3?
I didn't even get time to look at it.
Double check. Alright, so we're going to multiply pi by 3 and add pi over 6 to it. What do you get? 19 pi over 6. I want to multiply 3 pi over 2 by 3 and add pi over 6 to it. 14 pi over 3?
I got to be given that.
Yeah, that's what I got.
You get 20 pi over 6 is
2 pi times 3 plus pi over 6 is?
37 pi over 6.
Yeah. Got that one right.
So those are your x values that are related to cosine. Now if you're watching the video, I had to change my scale a little bit because I didn't have all the way up to 6 pi. So I adjusted where my y-axis was and I changed so that I now have from 0 to 6 pi so I can graph this. Cosine only starts at 1, 0, 1. So my 0, 1 point is now going to be pi over 6, 1. My point of pi over 2, 0 is now going to be 5 pi over 3, 0. 5 pi over 3 is just on the other side of 3 pi over 2. That point that's at pi negative 1 is now going to be at 19 pi over 6, negative 1. 19 pi over 6 is a little bigger than what value? 3 pi. That point of pi over 3 pi over 2, 0 is now going to be at 14 pi over 3, 0. 14 pi over 3 is a little bit bigger than what?
Then 4. It's a little bit smaller than 5 pi.
It's a little bit smaller than 5 pi. And that last one of 2 pi 1 will now be at 37 pi over 6, 1. So this is cosine. With those horizontal stretch. Yes, sir. And the horizontal shift. Questions on that? Now we just have to take our y's of -1, or +1, 0, -1, 0, and 1. Multiply them by 3 and add 2. So what's 1 times 3? Plus 2. What's 0 times 3? Plus 2. What's -1 times 3? Plus 2. 0 times 3? Plus 2. 1 times 3? Plus 2. Those are now my y values to the x values I already have plotted. So I'm going to do my final graph in black. So at pi over 6, I'm at 5. At 5 pi over 3, I'm at 2. I should have used another color besides neon green. 19 pi over 6, I'm at -1. And 14 pi over 3, I'm at +2. And the very last one of 37 pi over 6, I'm at 5.
Anybody else find it weird how the jump is tremendously different from the second point to the third point, and then the third point to the fourth point? See how big the jump is different? Did we do that right?
Well, 14 pi over 3, when you divide that, that's a little bit bigger than 4 pi, but smaller than 5 pi.
Anyway, it just looks different.
I probably put the point in the wrong spot just because I don't have a label, so of course, but it's somewhere in between.
Close enough.
So you're gonna try this one. All of your x's got multiplied by what number?
-1/2 plus
And added by, or actually, minus pi over 4. So you should have gotten negative pi over 4, 0, pi over 4, pi over 2, and 3 pi over 4. Oh. Okay.
Yeah, I got the first and second one.
Well, pi times a half is pi over 2 minus 1/4 is pi over 4, right? 90 minus 45 is 45.
Yeah, I got it.
3 pi over 2 times 1/2, or negative 1/2. Oh, they were negatives. Jesus. That's why. Okay.
Yeah.
So, negative minus that would make this a negative pi over 4. Times by negative 1/2 minus pi over 4 makes this a negative pi over 2. times pi by negative 1/2, you get a negative pi over 2, minus pi over 4 is a negative 3 pi over 4.
Yep, got that.
3 pi over 2 times a negative 1/2 is a negative 3 pi over 4, minus pi over 4 is a negative pi, because negative 3 pi over 4 minus pi over 4 would be a negative 4 over 4. 2 pi times a negative 1/2 is a negative pi, minus pi over 4 is a negative 5 pi over 4. Those are your x's. Now your y's, they got multiplied by what? They got multiplied by negative 1 and subtracted by 1. So 0 times negative 1 is 0, minus 1 is negative 1. This would end up being a negative 2. This one would be a negative 1. This one would be 0. And this one a negative 1. So there are my x's. There are my corresponding y's. And so when I plot, there it is. Negative. Questions? It's not a race. Take your time on the math because that can throw you off big time.